Hi everyone, we're going to solve logarithmic equations using the properties of logarithms. And you should already know your properties. And the first one we're going to do is log base 5 of 4 plus log base 5 of 2x equals log base 5 of 24. So before I do this, I'm going to write this left side as a single logarithm. So that's going to be log base 5 of 4 times 2x, which equals log base 5 of 8x. So we have log base 5 of 8x equals log base 5 of 24. Since my bases are the same, I'm just going to solve for x, and so x equals 3. And you can plug it in and check. And one thing you need to remember is for this x here, this quantity here has to be greater than 0, because the domain of a log of x, some base of an x, the domain of that, I'll just put equals y, is x has to be greater than 0. So just keep that in mind. Now, another one, we have 3, this is number 2, 3 times log base 4 of 6 minus log base 4 of 8 equals log base 4 of x. I'm going to condense this in two ways. I'm going to first do my power property and move this 3 right here. Then I'm going to use my quotient property and divide. So this is 6 cubed over 8. And then this equals log base 4 of x. So basically, now since my bases are the same, I really don't need to deal with that and just solve for x. I have 6 cubed is 216 over 8 equals x. So x equals 27. And it's valid because it's greater than 0. Next one we have is 1/2 log base 6 of 25 plus log base 6 of x equals log base 6 of 20. Now, what I'm going to do is go ahead and do like I did last time, condense this using my power property, and then that's going to be multiplied using my product property times x equals log base 6 of 20. So 25 to the 1/2 is like square root of 25, so that's going to be log base 6 of 5x, because this is just 5, equals log base 6 of 20. My bases are the same here, so I just have 5x equals 20, so x equals 4. Okay. The next one, we have log base 2 of 4 equals log base 2 of x plus 3. No, this is not. This is minus. Equals log base 2 of 8. So I'm going to use my quotient property and write this as a single logarithm. Now, my bases are the same, so I'm just going to solve for x. I'm going to cross multiply, and you get 4 equals 8x plus 24. Subtract the 24, so I get negative 20 equals 8x. So x equals negative 20 over 8. which equals negative 5 over 2. Now let's go ahead and check it. We put negative 2.5 here. This quantity here is going to be 0.5, which is still greater than 0, so it is a valid solution. And the next one, we have log base 6 of 2x minus log base 6 of 3 equals log base 6 of x minus 1. I'm going to condense the left side here using my quotient property. Write it as a single log. My bases are the same, so basically I'm going to cross multiply this. So you get 2x equals 3, this is over 1, 3x minus 3. So you're going to subtract 3x, you get negative x equals negative 3, therefore x equals 3. I have to check here that it's valid. I plug 3 in here, that's going to be positive, and I plug 3 into this one, and that's positive, so it works. And you can also check to make sure the left side equals the right side. Okay, we have another one. 2 times log base 4 of x plus 1 equals log base 4 of 11 minus x. This one only involves the power property, so I'm just going to move that here, take that off. Now my bases are the same, so I have x plus 1 squared equals 11 minus x. Now I'm going to square this out. This would be x squared plus 2x plus 1 equals 11 minus x. I'm going to move, since it's quadratic in form, I'm going to move everything over and set it to 0. Add the x, you get 3x. Subtract the 11, and you get minus 10. Now let's factor, so you get x plus 5 and x minus 2 equals 0. So we get our solutions as x equals negative 5 and x equals 2. Now when I plug in negative 5 into this one, that's going to yield negative 4. And negative 4 is not greater than 0. Because the quantity here, this whole thing, if that's x, has to be greater than 0. So we disregard that. When I plug in, oh, this is supposed to be positive 2, sorry. Plug in 2 in both places, it will work in this first quantity, and 11 minus 2 is 9, and it works here. So basically the only solution I have is x equals 2. Okay, I have 2 more here. We have log base 2 of x minus 3 times log base 2 of 5 equals 2 times log base 2 of 10. Now what I do is I go ahead and take care of these power properties. I've moved the power there. Take care of that. Now I'm going to condense this and write it as a single log using my quotient property. So we get x over 125, because our bases are the same, that's good, equals 100. So x equals 12500, 12,500. And the last one, we have log base 3 of c plus 3 minus log base 3 of 4c minus 1 equals log base 3 of 5. I'm going to condense this and write it as a single log using my quotient property. My bases are the same. I'm going to cross multiply here. So basically, I'll subtract c and add 5. And we get 8 equals 19c. So c equals 8 over 19. If I plug this in, you can kind of just like take a cursory glance. And it does work. And so that is my solution. Thank you and have a nice day. The next ones we're going to do are the ones that we have to, it's a little more complicated. And we're going to multiply by log base of a base. Thank you. Have a nice day. Bye-bye.